Oh, hey there, ladies and gentlemen. Oh, whoa, whoa, I don't see you. I'm hiding you from my own personal FBI guy. There you are. All right, so here we are. This is lesson 10.1. We're talking about the beginning of chapter 10. The cool part about this, folks, I don't know if you know this or not, but we're getting towards the end of the year here. Chapter 10, chapter 12, final. Season's over for us, folks. So what we need to do is take care of this whole 10.1 stuff. We're just talking about how to graph things. Um, it's not too shabby. It's a lot like 9.7 was that we just talked about. So square root functions. We have a parent graph of a parent function. It's just the square root of x. What's going to happen is you're going to plug numbers in for x. And usually you want to plug in numbers that are nice. And by nice, I mean you get an answer for them. But you could also just use your trusty calculator to get a not so nice answer with this decimals of some kind. So I just plugged in perfect squares. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. So I can plug those numbers in. What we're going to notice here is that we have a nice curved line. A square root function starts and then continues on in one direction. Yeah, that's a band I heard. And what we're going to do with this is we're just going to plug numbers in. You'll notice that my starting point of this is going to be 0, 0, and then these numbers were 0, 0. So those things are kind of helpful for us as we're trying to name the domain and the range. Remember, the domain was the x values and range is the y values. This is stuff that we've been talking about since like chapter 4 here. So this is important information. This is just the parent graph. So the way that we do this stuff is, again, we're just going to compare things by naming if things get reflected or not, if things go up at a steeper rate or not, if things just get shifted right, left, up, down, all that kind of fun stuff. So we're going to take care of all those things with all of this next topic of square root functions. So here it is. Our job is to graph this first one. It looks like my information is being blocked by my fat face. Let's move my fat face. I mean the stuff, because I can't move my fat face. All right, there we go. And what we're going to do is we're just going to plug in some numbers. I chose the same perfect square stuff, and we're just going to plug them in. So the square root of 0 is 0, and half of 0 is 0. So that's good to know. So that gets me an x and y of 0, 0. Yay. The square root of 1 is 1, and half of 1 is 0.5. So I go to the right one up half. And then the square root of 4 is 2, and half of 2 is 1. So I go to the right 4. 1, 2, 3, 4, and up 1. Square root of 9 is 3, and half of 3 is 1.5, so this is going to be a nice shallow one. To the right 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then up 1.5. So you'll see I have a very, very shallow curved line, and that is my square root function here. I forgot to put in this one. Square root of 16 is 4, half of 16 is 2. Okay, so notice that I did the square root of something first. That's like having the implied parentheses like we talked about at the beginning of the school year, and then we multiply by a half like we did also at the beginning of the school year. All we need to do now is name our domain and our range. So my domain is my x numbers. So for my x numbers, I have x is greater than or equal to, so this number for x is at 0, 0, right? So we have ordered pair 0, 0. My x is 0, and it's going to be getting bigger and bigger and bigger as I follow that line. So it's x is greater than or equal to 0. Now my y values, now I'm just making sure that you guys understand this is just y values for range, is also my y is 0, and it's getting higher and higher and higher up on this line. So it's going to be greater than or equal to 0 as well. These numbers that we used for our starting point are the same numbers that we end up using for our domain and for our range. So that's good information to know. You notice that this was not reflected. It stayed going up just like the parent graph would be. And it's also just a little bit more shallow. So it's a dilation of a half because the factor of 1/2 in front. All right, let's try another one. This one says the square root of x and then minus 1 at the end. Ooh. So the square root of 0 is 0, minus 1 is minus 1. So we have a 0, negative 1. Square root of 1 is 1, minus 1 is 0, so we go to the right 1, up 1. Square root of 4 is 2, minus 1 is 3, so I go to the right 1, 2, 3, 4, up 1, 2, 3. And the square root of, oopsies, I didn't write that down. Square root of 9 is 3, and then minus 1 is 8. So I go to the right 9 and up 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's not going to let me do it. I'm in the way, but it's up there. So what we're going to do is connect those dots. And this is your square root function with those beautiful arrow at the end. And this is going to be able to help me out with my domain and my range. My starting point was at a 0, -1. And that's going to help me with my domain and range again. So domain is my x value. So I have x is greater than or equal to the 0. And then my range is my y values. So I have y, and it's going upwards. So it's going to be greater than or equal to the y value of this number is at -1. Now this is all in comparison to the parent function. So our parent graph was at 0, 0. It was at 1, 1. It was at 4, 2. And it was at 9, 3. Did I do that wrong? Square root of, yeah, this last point's wrong. There we go. I was wondering why this looks so goofy. Don't tell anybody, especially someone who's smart in your household that knows math. So to the right 9, this wasn't square root of 3 minus 1 is 2. Right? Square root of 4 is 2 minus 1. Should have been a 1. So let's fix some of this graph that I was screwing up on. Don't tell anyone again. Our little secret in blue. So the square root of 4 was 2 minus 1, so we got a 1 here. To the right, 4 up 1. There we go. And then our next one was at 0. And then 9, we're going to be at 2. We're at 3 minus 1. We're at 2. There we go. And this one should have been at 1. All right. So now we've fixed things. That makes us much, much more happy. And our life seems more complete. So in blue, that was our graph that we just made from the original stuff. And then in purple is the parent graph. All right, so now we're correct. Woo! That was rough. All right, so this is how things work out. You'll notice that with this -1 on the outside, our entire graph shifted down 1. So there's just a translation of being down 1. And that's what happens. Now, when we have numbers that are on the inside, let's see what happens here. So I'm going to plug in my little table here. I'm going to choose numbers that work out really, really nice for us with this x plus 1. Actually, I'm lying to you. I'm just going to choose numbers. We're going to choose in a 0, a 1, a 2, a 3, and see what happens here, okay? Now, and I'm going to probably choose a -1 here too. Don't tell anyone. Because what happens when I plug in a -1 plus 1, I get 0. And the square root of 0 is 0. So I went to the left 1 and got a 0. That's going to be my starting point. It's important to find where we start. Now when I plug in a 0, 0 plus 1 is 1. The square root of 1 is 1. So I'm going to go to the at 0 up 1. And when I plug in a 1, 1 plus 1 is 2. Square root of 2 is not a very nice number. It's actually a 1.4. So I go to the right 1 and go up to 1.4. And I graph that. Same thing here, 2 plus 1, so the square root of 3 is also not a nice number. Square root of 3, oh, gross. It's giving me syntax errors. Do you know why? Because I typed it in wrong. And that's at a 1.7, so the square root of this one gets us to a 1.7. So just a little bit higher up. And then a 3 plus 1 is 4, so that's going to be a 2. And you'll see that I have my graph started here. And what we'll have is, again, we have our main point where things start at, which is really crucial. That helps me define my domain and my range. So because of this graph shifting to the left one, we can draw the conclusion with whatever's on the inside, it shifts to the right or to the left. And it goes exactly like our previous lesson did. It's the opposite of what you think. So the stuff on the inside goes the opposite direction of what you would think left or right. So this is numbers telling me to go to the left or right, but in this case it's just telling me to go to the left because it's the opposite of that one. So then my domain is my x values, and my x values are going to be the ones where x is greater than or equal to 0, because that was the point here. We have a negative 1 comma 0, so I need to change that. That was a negative 1. So my x values are from negative 1 going on in that direction. And then my y values are going to be where y is greater than or equal to 0, because it's getting higher and higher and higher onto my graph. All right, folks, that's all this lesson is. It's us just being able to state that it got shifted to the left, to the right, to the up, to the down, and all that kind of fun, cute stuff. If it gets reflected, it's going to go from being this line would just shift to being downward. If we could do that, it'd look like that, and it'll go down like that if it gets reflected. And it'll only get reflected if the number in front of our whole function is a negative, just like what we did with previous lessons. All right, again, this is the Berman Nation. We're signing off, and something's quit, so I quit. We're out.